Good afternoon. I'm Sean Devine, the founder and CEO of XBE. Happy to be here. A little bit about me. I like to tell stories, listen to lies, philosophize, but you'll enjoy none of that right now because this is a lightning talk and I don't have time. So meet me at dinner, but right now I'm going to tell you a little bit about Speedy model components. And my hope, I have two conflicting hopes. One is that all of you already know everything that I'm going to say and have saved yourself from the pain of not knowing it. The other hope is that none of you know, and you'll be wowed by what you're about to find out. So let's get to it. Okay. Sometimes fetching all model attributes can be very expensive. Let's imagine, for example, we're making a request for a component. We're going to request 20 instances of a model, and then for each of them, all of their children of a different type of model, and then a bunch of their children, and so on and so forth. And so that one request may have 200 different model instances that comes back, and by default, it's going to include all of their attributes from the server. That's the standard with JSON API plus Ember. And in a small app, that's not a big deal. In a test environment, maybe you don't care. But once you get to a situation where you have a lot of data or many components, or you're doing things that are a bit more complicated on the server or on the client, well, it matters. 4 reasons that I put up on the screen that it matters. First, it can cause a lot of unnecessary calculation time on the server. Now, you may all just have your data cached in clean columns in your database, and you're just fetching it and sending it down the wire, but we don't. So we do for some other things. We're doing some calculations, and it turns out those things can add up, especially if the application's been around a while and you didn't foresee the amount of data that you may have to deal with right now. So first problem, unnecessary calculation time on the server. Second problem, inflated payload size. Now, this is another one. Maybe that didn't seem like a big deal when you didn't have too many models, but all of a sudden you see a response come down and it's got 400K of data, and that request is being made again and again and again. And that can matter both for the network time and what happens on the client. So the third problem with fetching all of the model attributes when you don't need them is you have to parse them. And while our current client machines are pretty fast, the extra parsing burden on the client can add up, take time, and we don't want that. And the last thing is, when you have a big model in Ember data, you've got many relationships between many different types of models, they're going to all be defined as async. And that's sort of by necessity when you have that kind of setup. But in a given model or component context, which we'll talk about in a second, you don't usually want those model relationships to be async. You'd much rather assume that they're loaded and depend on that when you're rendering it. So these were the 4 problems that we found ourselves dealing with. And I know what you're thinking. Premature optimization is the root of all evil. Why are we worrying about these things when we don't have to? So I hear you, but sometimes optimization is not premature, and we were very mature, and we were having very mature problems, like how the heck do we maintain performance as our company and as our product had the success that we always hope for. So you probably know, or maybe know, that JSON API supports sparse field sets. So I think from the beginning, or at least from 1.0, the specification allowed for passing in the set of fields that you want per model so that we can get around this problem, so that the response will only have the fields for every one of the models, both the primary and the included, that we needed. And a good server-side implementation of this will just work if it's implemented the standard. So for example, we use JSON API resources, and that supports sparse field sets in a really nice way. Again, both for the primary resource that you're requesting and for the included resources. But if you rely on the standard sort of one version of every server resource approach with Ember data, which would be the way that most people learned, This isn't going to work because if you make requests with sparse field sets, then the single instance of a given resource or given model that you have in your client will have portions of its attributes changed and the other ones nullified when you update with sparse field sets from the server. So that's a problem because you may be sharing those, or you likely are sharing those same models in various places. And all of a sudden, in the one place, you have the data you need, and the other place, you don't. So what do we do? Here's the thing, relax. It's actually no big deal to implement a pattern with Ember data that gets around this. And these are the 3 steps how. So first, and it took us a little bit of time to figure out this pattern in a way that I think works in all situations, but this one has for a couple of years now. So when we're building a component and that component gets a little bit heavy and we can feel the load on the server or on the client for all these extra attributes, what we do is we take a model and we replicate it at the component level. So let's pretend that our model's name or our component's name was like fancy calendar, and we have a model which is user. In our components or our models directory, we'll say, okay, I'm going to make a new folder for fancy calendar and put a user model in it. All right. Then we'll implement just the attributes and relationships that we need on every model that component's going to use. So let's say we just need the name for the user, not the 40 other attributes that it supports on the server. We just will implement user model with a name on it. So on and so forth for every other relationship in the model. Now, it's a little extra ceremony, but no big deal. You match, as you're building your component, you just add what you need to the model that corresponds to the component. All right, that's step 1. And I just wrote up kind of the simple, little structure you'd expect. So components, public praise summary, and then in the model, I have a mirror of that. And then when I'm making a request, I just say, okay, I'm going to query public praise summary dot public praise, and that's how I get the components version of that model. Okay, that was step 1. Step 2 is we add an adapter to parse the attributes that are defined on the component models into the request to the server that specifies the sparse field sets that match it. So it goes recursively through the model and then its relationships and so on and so forth, and just builds up the set of fields that match what you've declared in the component model like this. All right, so we do that here. That's in the adapter, and then we need to map the endpoint path for the type. Like in this case, it's public praise, or this public praise summary dot public praise. We have to map to public praises or whatever the path is on the server. By default, that's just the plural of the dot split last item that you use once you get sort of used to a convention here. So you don't have to do anything fancy. You use a component model adapter. It'll do all this for you, and it kind of comes for free. The last thing you do is add a serializer that normalizes the payload of the response into the component model. And basically all that's doing is it's taking the non-namespaced response that's coming from the server and renamespacing it based on where it was requested from. Here's the thing though, you build, and of course I don't have an add-on for you to use to do all this, but sorry. Again, it's a lightning talk. If I was here for the full talk, you'd have an add-on, but not this. So anyways, the serializer will build the component models from the payload, and there you go. Now, again, you don't get any code in a lightning talk. So, sorry, no code. So to end with a little quote, Pankaj from our team at XP, he did a decent amount of the sort of construction of both the adapter and the serializer that we use that makes all of this magic. And in his latest commit, I saw this and thought I'd share. He said, "Thou shalt think of me when you create a component model and not a serializer with it." And that's just me saying to you that if you like this model, it's actually not that big of a deal to write the tooling to make it work, and you can have your cake and eat your sparse field sets too. Thanks.